In this lecture, we're going to learn about iterators. Iterators are pointer-like types that we can use to traverse different kinds of containers without caring about the internal structure of how the container is set up. So for example, in our C++ program, we might have a container that is based on an array. This is what we have seen for box container. This is what we have seen for std vector. It is actually the same thing we have with std array, but std array is a fixed size container. So we might have containers that are modeled to have data contiguously in memory. So for example, the piece of data we have here in slot 1 and the piece of data we have in slot 2 here, they are contiguous in memory, and you can really move from one element to another by just incrementing by the size of the type that you are storing in memory, doing something like we did for pointer arithmetic. But it is also possible to have data in a container stored in a way that the data is not contiguous. So for example, if we have this container here, we may have the data to go from this place to this place. We may go from here to here. We may go from here to here. We may really have data scattered out in memory and have a container really wrapping around those pieces of data, and have iterators help us navigate through all these different kinds of containers in a unified way. Hopefully you can really understand this. So this is the big idea behind iterators. They allow us to navigate or traverse containers using the same syntax, and it doesn't really matter how the container is structured on the inside. All it matters is that it supports the iterator interface. Now, each C++ container is going to define its own iterators, and we're going to have a chance to see this in details in the next chapter when we explore different containers. Now, once we have iterators, we can traverse our container. For example, we can go from the beginning all the way to the end. Some iterators even allow you to traverse backwards, so we can do something like this. And containers provide methods that give you iterators that you can use to traverse your iterator. For example, we can get a begin iterator, which is going to be pointing to the first element in the collection. We may get an end iterator, which is going to be pointing past the last element in your collection. This is really important to understand. Some people might think that the end iterator is going to be pointing to the last element in the collection, but that's not the case. The end iterator is going to be pointing past to the last element. And what this says is that you can't dereference the end iterator because it's really not pointing to a valid piece of data. If you want to get the data, you have to go to the element in front of the end iterator. That's where you're going to find a valid piece of data you can use in your C++ program. Now, let's see how we can do these things in code. We're going to be using a few containers we already know about. So we're going to look at std vector here. We can set up an std vector and put in the data. And we can get a begin iterator and an end iterator using this syntax. Now, we have said that iterators are bound to the containers they work on. And this is what we are doing here. We are saying we want an iterator that can be used to traverse a vector of integers. And if you happen to try and use this iterator, for example, to traverse a vector of double or dogs or cars or whatever, really, that's not going to work. The iterator is bound to the container and the data that is contained in that container. You should keep this in mind. So we say std vector int, and we say : iterator. This is going to be our type, and this is going to be an iterator that can traverse a vector of ints. We're going to give it a variable name, and then we're going to say the container name and say .begin. We're going to call the begin method, and this is going to give us a begin iterator, which is going to be pointing to the first element in this collection here. We can also get an end iterator, and the syntax is what you see here. We're going to call it end it, and we're going to say the container name .end. This is going to give us an iterator, which is going to be pointing past the last element in this collection here. This is important to understand. The end iterator is not going to be pointing to 44. It is going to be pointing in memory past the last element we have in this collection here. And we will have our iterators now ready to use. Once we have them set up, we can use them like we really use regular pointers. For example, we can dereference them. And if we dereference the begin iterator, which is our it here, we're going to get the first element, and we can test and see if the current iterator we have is not equal to the end iterator. We can do something like this. And because the begin iterator is really not equal to the end iterator, this is going to give us a false. So if we go down, we can also increment on the iterator. And the iterators really are designed to mimic the behavior we have on pointer arithmetic, to be able to use the iterator like we use pointer arithmetic to move between elements. You already know that through pointer arithmetic, we can increment a pointer and move to the next element. We can decrement a pointer and move to the previous element. This is the same kind of behavior iterators are mostly designed to mimic. So that's why we can call the plus plus operator here to move to the next element. If we increment and print what we have in iterator, we're going to see that this is going to be pointing to 22. That's what we're going to see right here. And if we test and see if it is not equal to the end iterator, this is going to be false because at this moment we will be at 22 here. So this is different from the end iterator. You can keep incrementing until you hit the end, and once you hit the end and increment again, now the iterator is going to be pointing past the last element, and this statement here is going to return true. So we can use the same logic here to traverse a container in a unified way, regardless of how it is structured on the inside. So we can do something like this and set up a function to print a collection. This is going to be a template function. It is going to take a t, and this is going to be whatever kind of container we want to print out. We're going to set up a begin iterator, and we're going to loop around, checking to see if we haven't hit the end iterator, and we say while it is not equal to collection, and this is how we do this. And if we are not at the end, we are going to dereference the current iterator and print whatever data we are pointing to, and then we're going to increment to move to the next element. This is going to keep running until we increment and get the end iterator. This is going to be false now, and the test is going to fail, and we are going to finish and print the closing square bracket here. And this is how we can use iterators to traverse our containers. This is nothing complicated. You just have to wrap your brains around this, and you're going to be using this all over the place to traverse your containers in C++. Okay, once we have our function set up, we can set up a vector of int and put in the data. We can set up an std array of int and put in the data, and we can call this function to print the data without caring about the differences in how std vector and std array are set up. All we want is to support the iterator interface, and the iterators are going to be picked up and used in our print collection function, and everything is going to fall in place, and this is really cool. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Iterators. We're going to grab the template files and put them in place. And let's open this up in Visual Studio Code by dragging and dropping here. Let's do this again. And this is going to give us our main CPP file that we can play with. And we're going to be playing with iterators here. We're going to include std vector, or vector to be exact, because we will use a vector. We can also include array to use the std array built-in container. We are going to set up a bunch of containers. We can set up std vector and std array as we do here. And then we're going to set up iterators that we can use to navigate through these containers here. So let's go down and set up an iterator that we can use to navigate through int1, which is our std vector here. So we're going to say std vector int, and we're going to say colon iterator. And this is going to be the iterator to the beginning of the collection. Let's say it begin. And we're going to say equals int1 and say begin. This is going to give us our begin iterator, and it is going to be pointing to the first element in the collection. In this case, it is going to be pointing to the 11 value here. And this is something you should know. Now, we can also set up an end iterator, and the end iterator is going to be pointing past the last element in our collection. So you can think of this as if there is an element beyond the 44 which really doesn't contain valid data, and the AND iterator is going to be pointing to this element here. And we can get to the AND iterator by saying std vector int and say iterator, and this is going to be it AND. This is how I am going to say this. You can say it however you want, and we're going to say int1 and say AND. This is going to give us an AND iterator which is going to be pointing past the last element in our collection here. Now, once we have these iterators, we can use them to read data in our container, change data in our container. We can even use them to navigate using pointer arithmetic-like operations. So for example, we can print out the first element in this collection using our begin iterator. If we dereference it, we will get the element it is currently pointing to. So if we go in and print the element it begin is pointing to, we're going to get the first element here. Let's try and change this a little bit. And we're going to say it AND here to make this work. So what this is going to do is to dereference our iterator and get the element that the iterator is pointing to. Because an iterator is really like a pointer, but it is a unified pointer we can use across different kinds of containers in the C++ template library. If we dereference this, we will get this 11 printed out, and then we can test and see if the current iterator is not equal to the AND iterator. And this is how we check to see if we haven't hit the end of our container to be able to manipulate our data within the valid range of values. So this is what we can achieve with this. If we dereference this, we will get this 11 printed out again. So let's pass this through our compiler. We're going to use our GCC compiler. The build is going to be good. As you see here, we can bring up a terminal window and try to run this. If we run Rooster, we will see that we see first element is 11, and the current iterator is not equal to the AND iterator. This should really use a double pair of equal signs. So what we can do is increment our iterator and see what we get. And by incrementing, we can achieve the moving from one element to another. So let's grab what we have here, and we're going to go down and say it begin, or let's increment using the prefix operator. We're going to say it begin, and we're going to go down and print the data again, and we're going to be using the same code really, but we're going to change this to say that this is going to be pointing to the second element, because if we increment an iterator that was pointing to 11, we're going to change and make the iterator point to 22 using pointer arithmetic-like operations here. So if we print this, this is going to print the 22, and this is going to give us a false because the iterator is not yet pointing to the same location as the AND iterator. This is what we mean here. We can pass this through our compiler. The build is going to be good, so we can clear and run Rooster. We're going to see that the second element is 22 now. We can repeat the same operation really. So let's copy this and go through this line by line so that you really see what is happening behind the scenes. Now our iterator was pointing to 22. We're going to increment it and make it point to 33 here. And if we print, this is going to give us 33. And this is going to be a false because our iterator is not yet pointing to the same location as the AND iterator. So this is going to be a false. We should really change this to say third element because that's the case here. And we can build our program. Let's pass this through our GCC compiler. The build is going to be good, so we can clear and run Rooster. We will see that we have the third element printed down. At this point, we are pointing to 33. We can go down and increment again. So let's copy this and put this below. And the situation we have is we had an iterator pointing to 33. We are going to increment it and make it point to 44. And if we dereference here, we'll get to the 44 printed out because we can dereference an iterator like we dereference a pointer. That's how they are designed. And if we test and see If we have hit the end, this is going to be a false because the current iterator is different from the iterator pointing to the AND iterator here. So this is the situation. This is going to be a false. Let's try and pass this through our compiler. We are going to use GCC as always. And the build is good. We can clear and run rooster. This is going to give us a 44. Now we are already pointing to the last element in our collection. So the situation we have is we are pointing to 44 and we are going to be having an AND iterator pointing to the element past the last element. This is our AND iterator, what we have in green here. Now, if we increment this iterator, which is pointing here, we will get it to point to the same location as the AND iterator. If we try to dereference the AND iterator, we will get some junk data because the AND iterator is really not meant to be dereferenced. It is meant to be checked against to see if we haven't hit the end of our container. So if we dereference it, we can expect to get bad things to happen. But the good news for this is that we can check and see if we have hit the end. So let's go down and try to do something like that. We will increment and see what we get. We're going to increment and put the data here. So this is going to be a junk element because we will be dereferencing an iterator which is really not meant to contain some data. That's why I am saying junk here. But what I want you to see is that if we increment now, it begin will be equal to it and this is going to give us a true if we pass this through our compiler and run the program. Let's do that. We're going to run this task to build with GCC. The build is going to be good, so no compiler error. Let's clear and run rooster. And you will see that the junk element will be 0. This is really undefined behavior. You may get anything if the memory location you are trying to dereference, for example, belongs to the operating system or is being used by another application. You might even get a crash. So it is really not advised to dereference an AND iterator. And at this moment, because we have incremented from the 44 here, we will get our itBegin iterator pointing to the same location as the AND iterator. You should really know this iterator is not meant to be dereferenced. But here we are getting a 0, but sometimes you might get a crash. This is not good. But the most important thing is to know that we have hit the end and this is returning true. And this is really cool. We can compare our current iterator to the AND iterator and know that we haven't hit the end of our container. Now that you know how these things work, we can set up a function which is going to loop through any kind of container that supports begin and end iterators. So what we can do is set up a function like we saw in the slides. We can set up a function to print a collection. The collection is going to be our template parameter here. We will grab the begin iterator and use it as a starting point, and we will dereference it and print whatever is pointed to by the iterator. And then we will keep looping until we hit the end. And once we hit the end, we're not going to jump into the body again. We will hit the end of our loop and we will print this closing square bracket here. Now that we have this function, we can go down and use it to print any kind of collection. So we can really take out even everything we have here, or we can leave these in. No problem with this. So we can take out the closing block comment here and put in a separator. And we will go down and print out all these collections here. Notice that std vector and std array are really different in how they are implemented, but we will be able to use the same iterator interface to print these collections, and this is really cool. This is going to work even if the data you are representing in memory is not stored contiguously. We're going to see a bunch of containers that work that way. For example, std list. These things are going to be working in ways that the data is really scattered around memory. So you may have a piece of data at memory location 1 and have another piece of data at memory location 100, and you will just be navigating through that mosaic of data using pointers, and iterators are going to make it super easy to work with all these crazy kinds of containers we can have in our C++ programs. So we're going to go down and say stdc out and say int1. I think this is the collection here. And we're not even going to put a new line character here. So we're going to say print collection and pass in int1. This is going to be an std vector of integers. We can go down and say std out and say int2. And we can say print collection and say int2. And we're going to see how this works out. We can pass this through our compiler. The build is going to be good, so we can clear and run Rooster. We'll see that we will print our data. int1 contains 11 all the way to 44. We can print our std array, and we're going to see that it contains 100 through 400. And everything is really working well. Hopefully you can use this as an example to understand how you can use iterators to navigate through elements. And this is really cool. This is going to be our starting point to learn about iterators. As we progress in this chapter and other chapters, we're going to see much more uses for these things, and they are really cool. I think later in the course, we will also have a chance to build iterator support for our own containers like box container, and that's going to be really cool. So this is all I had to share in this lecture, showing you how you can use iterators. The main strong point for iterators is that they can allow you to navigate through all kinds of crazy container types using a unified syntax. And that's going to make working with your containers much more easy, because a lot of C++ developers already know about iterators. So if they use your container with a function like this, it is going to work out of the box, and you don't even have to communicate with them. They will look at your container and know how to use it right away. And this is really cool. We are going to stop here in this lecture. In the next one, I am going to show you that it is possible to use iterators to traverse subranges of your containers. So for example, if we have a collection like this that goes from the beginning all the way to the end, it is possible to set up functions that only works with small ranges from your container. For example, we may be interested in working within this range, and we're going to see how we can do that in the next lecture. So go ahead and finish up here and meet me there.